So welcome back. Now we're going to look at working through at least one example of each type so that you understand what you're doing here. So again, what we're working on is finding the vertex and axis of symmetry when we are in the three different forms of a quadratic function. All right, so I'm going to move on to new page so that I can work through some examples. So let's start off. Example 1. Let's say that we have y equals 3x squared plus 6x minus 10. So let's start with this one. We'll see what happens here. All right, make sure it's focused for you. Oops, hold on a second. Sorry about that. There we go, that's better. Okay, all right, so first thing we need to do is determine which form this is in. So hopefully you remember that basically you could look even at parentheses. So standard form has no parentheses. Intercept form will likely have 2 sets of parentheses, and vertex form will have 1 set of parentheses. So this one has no parentheses, so we know that we are starting off in standard form. So if we go back and look at our notes that we took, to find the vertex and axis of symmetry when we're in standard form, we need to do negative b over 2a. Once we get that, we're going to fill it back in and figure out what the y is. All right, so here goes. So we need to do negative b over 2a, and that's going to tell us what the x is. All right, so negative b would be negative 6 over 2a is 6, so that equals negative 1. So here's what we know. We know that our vertex is at negative 1 something, because we just figured out using negative b over 2a that the x value of our vertex is at negative 1. All right, now we need to go through and figure out what the y is. Well, since we know x is negative 1, I'm just going to go up here and fill in negative 1 for x. All right, so we need to do 3 times negative 1 squared, which is 1, minus 6, because that's 6 times negative 1, minus 10. So 3 minus 6 minus 10, if I'm doing that right, that looks like negative 13. So now we know that our vertex is located at negative 1, negative 13. And now we also know that the axis of symmetry is going to be the imaginary line that goes through the vertex. And since it's a vertical line, it's going to go through the x. So now we know that the axis of symmetry is at x equals negative 1. So there is our answer. All right, so just to recap what we did, since it was in standard form, we used negative b over 2a to figure out what the x was. Once we know what x is, we fill it back in to get what y is. So now we know that the vertex is at negative 1, negative 13, and the axis of symmetry, which is the imaginary line, it's a vertical line going through the vertex, which is located at x equals negative 1. All right, next up, let's do, for example 2, so, all right, let me think of a good one. How about y equals 2, parentheses, x plus 7 and x minus 3. All right, so first thing we need to do is determine which form this is in. So looking at this, I see 2 sets of parentheses. This is factored, so I know that I am dealing with intercept form. All right, so in order to get our vertex and axis symmetry from intercept form, so let's take a look at our notes. So what we need to do is average the two x-intercepts and then fill it in, and then we know the axis of symmetry. So since we're in intercept form, I need to average the two x-intercepts. All right, so first up, we just went through how to solve these. So let's say if we have this, we know that for this one, x would equal -7. And for this one, x would equal +3. So -7 and +3 are the two x-intercepts. So what I'm looking for now is what is the middle of those two numbers? Well, one thing you can do is just average them together. So in order to get what x is, I need to average -7 and +3. So -7 and +3, so -7 plus 3 divided by 2, because that's how you average. You add them together, divide by how many there are. So that's -4 divided by 2, so that's -2. So the middle of -7 and 3 is at -2. So now I know that the vertex is -2 something. All right, now to figure out what the something is, I just have to fill this back in and work it out. So I have 2. All right, x is -2. So -2 plus 7 would be 5. And -2 filled in here, so -2 minus 3 would be -5. So if I multiply all that together, we get -50. So I know that the vertex is at -2, -50. So just to recap what we did, we found the x-intercepts, which are -7 and 3, averaged those together, which is just finding the middle. So if you think about it, you know, from -7 to +3, that's a distance of 10. So halfway between those would be a distance of 5. So if I went 5 spaces this way and 5 spaces that way, I would land at -2. So that's another way of doing it. Same thing as just averaging the two numbers together. So then once I found that x was -2, I just filled it back into the equation and worked it out and got that y is -50. So now I know the vertex is located here, which means the axis of symmetry is a vertical line that goes through the vertex, which means it is located at x equals -2. So now I have the vertex and axis of symmetry. All right, that was intercept form. So I guess next one should be, you got it, vertex form. All right, here we go. Example 3. So let's say that y equals -2 parentheses x plus 4 squared minus 5. All right, so standard form has no parentheses. Intercept form is going to have 2 sets of parentheses at least, or it should, not always, but just go with it. And then vertex form is easy to recognize because we have 1 set of parentheses that's squared. So this one is definitely in vertex form. So, ooh, that's kind of weird. So this one is in vertex form. All right, I don't know about this marker. All right, so vertex form. So if we go back to our notes that we took, when we have a quadratic in vertex form, we look right here to get the vertex, but it's going to be the opposite sign. So this is -h. This one means that the vertex is going to be +h. The k is the same, but the h is different. All right, so if we look at this one, then we can look and tell right here that our vertex is going to be, since this is +4, our vertex is located at -4, -5. So that's easy. And then, because we know where our vertex is located, we know that the axis of symmetry is going to be located at the x value, which is -4. So the axis of symmetry is x equals -4. All right, there you have it. I hope those help you and are enough examples. And remember, you can always go back and replay the video. Don't be afraid to watch the video twice. So what we were doing again is finding the vertex and axis of symmetry in each of the different forms. So standard form, we use -b/2a, fill it in. Intercept form, we find the two intercepts, find the middle, which we can do by averaging, and then fill it back in. Vertex form is the fan favorite because we can look right there and recognize the vertex is just the opposite on the x, but then with the y. And then in all of these, once we know what the vertex is, we know that the axis of symmetry is a vertical line that is going through the vertex. So once we know where our vertex is located, we can easily find our axis of symmetry. All right, that takes care of it. And now you should be good to go to work on your assignment.